and welcome back to Shortcuts. I'm your host, Adam Dudley, and today we're going to discuss how to normalize finding severities across multiple scanning tools. This topic is exciting because it's critical to moving vuln management programs from dysfunctional to functional and successful, and sometimes from impossible to possible in the case where vuln management resources are scarce. So our expert guest on the topic is an experienced and deeply technical, savvy field engineer guy. He also has a side hustle programming, lighting, and effects for music shows, which I happen to think is very cool. So please welcome Aaron Attarzadeh, or A2 as we call him at Nucleus. Welcome back, Aaron. This is your second time on the show.
Thank you for having me. Really excited to be here today.
Fantastic. So before we do dive in, can you give us a quick take on what we mean when we're talking about normalizing severities on vulnerabilities coming in from multiple scanning tools?
Vulnerability scanners, every single scanner has their own way of scoring a vulnerability, whether it's based off of their secret sauce, whether it's based off of CVSS score, or it's based off of just manual triaging of vulnerabilities with rules. And as we move to a state of having multiple vulnerability scanners, it's very difficult to be able to say that, a critical in one scanner versus a critical in another scanner versus a critical in the third scanner. And C-suite turns to you and says, hey, what is the most critical vulnerability in my environment? Well, you really don't know because everyone has their own way of measuring what a critical is. So at Nucleus, we're trying to normalize all that information so that rather than looking at 3 or 4 or 5 different data sources and writing rules into 5 different data sources, you only really have to write logic into one. And that scanning and that scoring of a vulnerability is done only once for the entire organization.
We have a lot of enterprise customers, right? And sometimes, correct me if I'm wrong, they're using a dozen or more different scanning tools across the org, from everything from network scanning, endpoints, to cloud, to application, to repos. Like they're running a lot of different scanning tools. So if I'm hearing you correctly, there are every one of these scanning tools has a different lens or a different perspective on how they rate the severity of vulnerabilities. And obviously some of them, there's overlap on scanning tools in the enterprise environment. And so you're telling me that all of these different tools that the companies are running, they're all feeding different severity data points back to the user?
Yeah. And a lot of it is still based off of CVSS, and of course they add their additional touch and their additional flavor to give their own true vendor risk score to provide value. And at Nucleus, we can bring in all that information, marry it with asset metadata, also marry it with Mandiant threat intelligence. Really, what's most important to the customer, rather than just what is the attack vector itself, to provide a true severity rating.
That sounds like a real impossible mess to do it without a tool like Nucleus. And I don't even know, do you even know how folks traditionally approach this? Without a tool like?
Yeah, I do actually. I have a few customers that when they first approach us, they bring us a matrix. And that matrix essentially is, what is the severity? And then tied to what is the CVSS score? And then also an additional, what is the specific vendor risk that the vendor attaches to it, and get a number. And that number is essentially a weighted number, and it can be different plus calculations to get that number. So they have to do that for every single scanner. So they manually have to go in and normalize, create that weighted score, and they're doing it manually, and it's crazy.
Now you use the word matrix. Is that code for spreadsheet?
Yeah, it is. It's an actual. Okay. I've seen customers break full blown matrices where they are critical CVSS score of 8.
Yeah,
they're manually doing it. It's incredible.
Wow. Yeah, I had to ask because we talk about spreadsheets a lot in our various marketing communication, because we know there's still a big group of you out there that are using spreadsheets to do vuln management. Bad. Don't do that. So cool. Thanks, Aaron. So, now that we know that, would you please share some ideas on what problems Nucleus solves with regards to normalizing that multi-source scan data so it's not a big mess?
The first challenge is actually, before we even reach the vulnerabilities, before we actually even look at the data within Nucleus, is actually the Nucleus data model. So at Nucleus, when we ingest information, we ingest data from anywhere. The first thing we do is normalize all the keys in every single data set. So in one source, if a vulnerability name is vulnerability _name, versus another source, the vulnerability name is vulnerability space name.
Mm-hmm.
We normalize it so that regardless of if it's vulnerability underscore name or vulnerability space name, when you search for the vulnerability name in a rule, you only have to write vulnerability name. You don't have to pinpoint specifically this data source with this type of key, this data source with this type of key.
Okay, so we consolidate that all into one key within Nucleus. We consolidate all the different keys from the different scanning tool, and so you just have to use one key within Nucleus when you're talking about a severity or vulnerability, right? Yeah,
exactly. So everything conforms to the Nucleus data model on ingestion.
Mm-hmm.
That also means that whether you're writing rules or whether you're even pushing information out of Nucleus, everything is in the same Nucleus data model. So that's like the first thing that starts from right in the beginning of ingestion.
Right.
The second part is the asset metadata context that comes in with your scanning sources, that comes in with the cloud connectors, that can even come in with spreadsheets. All that information after the asset, of course, is correlated across the multiple different data sources. All that information is dumped on a single asset record. So if you have metadata from, let's say, Tenable, because Tenable provides great metadata, and then you also have agent information from, let's say, CrowdStrike. When that asset is correlated, you have a single asset record that has all the Tenable and all the CrowdStrike information on it. From that information, we can then start triaging and creating risk attributes for these assets. So scoring business criticality, data sensitivity, if it's publicly facing or not, or if it's in scope for compliance. But just scoring these assets isn't enough, because an asset could be, let's say, business critical, but business criticality to us is not a very important metric. So we actually weight the different categories. So let's say network exposure is of the most important factor to an organization. They would actually rate network exposure at a higher risk than business criticality. After we set the risk attributes for the assets, we then move over to what's called the findings processing, which is where we actually start to triage vulnerabilities and essentially assign risk to assets. So you have all of the normalized and correlated values from all the scanning sources, of course, to key off of. But you also have additional information like Mandiant. So Nucleus automatically ties in with Mandiant out of the box. The moment you adjust vulnerabilities into Nucleus, Mandiant is automatically put side by side that vulnerability. And then you have the option, in this case, to take action and leverage Mandiant to prioritize vulnerabilities. So you get things like exploitability, 0-day, Mandiant risk rating, exploited in the wild that you can leverage. On top of that, CISA BOD, EPSS score, recorded future information. All that can be paired alongside the asset metadata that we ingested earlier, as well as all the risk attributes to prioritize what is a true critical to the organization, not just what a critical is in the attack vector itself.
Right.
A critical vulnerability on a Raspberry Pi sitting on your desk should not be of most importance versus a critical vulnerability on a publicly facing EKS cluster, right?
Of course. And to be clear, Mandiant, we have a custom vulnerability intel feed from them, and actually that's included with your Nucleus subscription, right? It's no additional cost. Right. People don't have to bring their own subscription for Mandiant, right?
Yeah, put side by side in the console, and then you have the option to say, yes, I want to use that, and then leverage that to prioritize vulnerabilities.
Yeah, and we expose a lot of that juicy Mandiant intel to the user, right? So they're not just getting a few little data points here and there. They get real rationale as to why Mandiant's 300 plus human analysts have rated a vulnerability this way or decided that it's this level of threat.
Correct.
What about SLAs? How does that tie in here?
After a vulnerability has been scored, after an asset has been given a risk score, there's a few different ways to do SLAs, right? Because people do SLAs based off of criticalities. People do SLAs based off of business criticality of the asset. Some people leverage the Nucleus risk score to do SLAs based off of. I personally believe that the Nucleus risk score the people leveraging the Nucleus risk score to start rating SLAs, it encompasses all of the asset metadata, all of the risk calculation for the asset, plus the vulnerability already done, then gives you a holistic risk. And this holistic risk, again, is a normalized risk across every single data source. So you could have a source like Sneak, you can have a source like Tenable, two completely different assets that it's scoring, right? They're completely different types of assets. But the risk score is the exact same. The risk, the 0 to 1,000 scale is the exact same. So you no longer have to convert the 0 to 300 for one source versus the 0 to 1,000 for another source. Nucleus already encompasses that and takes care of that for you.
Right. And to be clear about that as well, in that our risk scoring algorithm is transparent, right? We provide our customers with a white paper that shows the math and how we do it so that there's no black box kind of scenario. There's no opaqueness. They can really see into that and know exactly how that's being done, right?
Exactly. Yeah. After I get off every call, I pretty much get an email every time. Someone is interested in seeing the white paper that explains the actual math behind it.
Right.
It makes me really happy to know that we're very, very transparent about that, because at the end of the day, like, that's what companies are using to measure their risk.
Yeah.
So ensuring that that's publicly facing is important.
Nothing behind the curtain here, folks, that we won't show you. Great. Well, thanks for that, Aaron. So I think we've given everybody a good sense of what we're talking about when we're talking about normalization. So let's dive into Nucleus and look at some examples of how our customers are using the Nucleus automation engine to normalize severities on vulns, and when they're coming in from different scanning tools that they might have connected.
If we jump into the asset management window, you'll see that within the assets themselves, that there are multiple assets that have multiple different icons next to them.
Yes.
This is when an asset has been correlated across multiple different data sources. Now, it's not as easy as just saying, hey, host name A, host name B, and match them and merge them. There's actually some additional logic behind it, where every single data source has its own way of depicting a unique asset, and Nucleus is aware of the different ways to actually correlate them.
Right.
So we're able to dedupe and create a single asset record for multiple different data sources. Now, if we drop into an asset record, we'll see that we have additional metadata at the very bottom. This metadata can be leveraged when we start going into things like automation and asset processing, when we want to prioritize an asset itself. So we want to start assigning the risk attributes for the asset. And this is kind of the step one before we get into the vulnerability scoring, because maybe we want to understand how important that asset is to the organization before we assign a vulnerability risk score to it. Right. So within the asset processing engine, you can pinpoint on any single data source within the same rule. So you only have to write one rule, and you can triage multiple different data sources. You don't have to write multiple different rules here. And it's as easy as saying something like, Qualys tracking method is maybe like Q agent, or tenable device type is host. You can write a bunch of different logic to then take action and assign risk attributes. Right. Now, risk attributes range from business criticality, data sensitivity, network exposure, and compliance. In addition to setting manually a risk attribute, you can also leverage what we call dynamic fields, which is the ability to pinpoint metadata on an asset, and rather than manually mapping it, just saying, hey, look within the asset itself, look inside of the metadata of that asset, look at the criticality, or let's say look at Snow, what Snow is bringing in from our CMDB, and then look at the criticality field. So and
sorry to interrupt you, but so the reason you're able to do this dynamic ticket or this dynamic fields activity is because that key right there, criticality, that's been normalized by Nucleus for you automatically, and it covers every source you might connect to Nucleus for vulnerability scan data.
Correct.
That's exciting stuff.
Yeah, this is one of the biggest value props for our customers when they start bringing in multiple different data sources, is leveraging the dynamic fields.
And this wouldn't be possible without our normalization technology.
Correct. All right, now that we've set the risk attributes for vulnerability, let's jump in and actually start prioritizing vulnerabilities themselves.
Okay.
If I click on add rule here, what I'm going to do is I'm going to write a rule that's going to pinpoint 20 different data sources at the same time without actually mentioning a data source.
Fantastic.
So if I click on the plus button here, you'll see that there is no Tenable name, Qualys name, etc. It's just severity name, description, path, solution, because all the data is normalized on ingestion to the Nucleus data model. So first thing I'm going to do is I'm going to scroll down and click on exploit rating. Say exploit rating is wide. Next part is, let's say a true critical to me, a true critical to my environment, to my organization, is if it's a 0 day. 0 days are always a big no-no. So we'll say, yes, it is a 0 day. Maybe I'll also want to add the Mandiant risk rating. Say Mandiant recognizes this as a critical, or maybe I want to even include a high for Mandiant.
Sure.
And on top of that, I can also pair in things like EPSS or CISA-BOD. In this case, I'll say if it's a CISA-BOD vulnerability. Yes.
Okay.
So from the vulnerability standpoint, that to me, that's my organization. That is a true critical. But I may have 150,000 assets. Those assets are being organized into business criticality. I have those assets already being scored and recognized as what is the most critical asset to my infrastructure.
Mm-hmm.
So I can come down to asset criteria. I can click on business criticality, and I can say these vulnerabilities, but specifically to the most critical assets in my environment. I can also say network exposure.
Yep.
Assets that are publicly facing. And of course, I can pair any additional asset metadata that I want here. Let's roll with this example. Yes,
I'm going to interrupt you real quick. So the reason also that this is possible, so we're offering users a single key here, or a single value, like critical or external when it comes to business criticality or network exposure. And these assets might be coming in from many different sources, just like the vulnerabilities, right?
Correct.
And so that's, again, another example of normalization where, these properties may be coming in from different data sources, but Nucleus is normalizing that into a single key that's super convenient to use in these automation rules.
Imagine having to juggle 20 different values, 20 different names for the name critical.
Oh man, I don't envy the folks. We love you, security practitioners, but we don't envy you if you're doing this manually. We want to help.
We do. All right, let's jump into actions and let's see now what's possible. Okay. So after we've referenced this, right? So, and keep in mind, I never actually keyed on a CVSS score. So CVSS score in this case could be 3, could be 4.
Sure.
Rapid7 or Tenable or CrowdStrike could be measuring these vulnerabilities as mediums or lows.
Sure.
So again, we're moving from what's an attack vector-based critical to what's a true critical to my infrastructure.
Yep.
So the first thing I'm going to do is I want to assign a severity. So I'm going to say this is an absolute critical to me. I can say that Mandiant recognized critical, that is publicly facing and on a critical asset.
And CISA as well, right?
Oh, yes. And plus CISA-BOD rule. Perfect. I can also say, let's set the due date of these vulnerabilities. So now I can start assigning SLAs. You can choose to assign this SLA to today from when the rule ran, or from when it was discovered by the tool. So if you are ingesting on Wednesdays, if you're scanning on Wednesdays, but you are not ingesting until the next Monday, and you want to ensure that your SLAs are 30 days from when this vulnerability was found, you can choose to set your date on that Wednesday rather than the Monday.
Yeah.
So I'm going to set this to 30 days from now. And on top of that, given that this is the most critical vulnerability to my entire organization, I'm going to pin this to the top of the list, because this is the first thing that all engineers should see the moment they log in.
Yep.
Speaking of engineers, I want to also assign these findings. Now in Nucleus, you're able to have assets that have multiple different owners on them. So because we're normalizing all the data, whether it's from your spreadsheet or from Snow or from Rumble, whatever that is, you have all the owners presented on the same asset, regardless of where the source is. So let's say, for example, critical vulnerabilities, most important vulnerabilities in my entire organization, I want to assign these to the stakeholder of the asset.
Yep.
I can go ahead and first I want to assign it to the team. So we can say this vulnerability is going to be assigned to the support group of that team. But in addition, I want to assign it to the stakeholder of the asset. So I can say asset.metadata.stakeholder. Now, Nucleus is dynamically assigning these vulnerabilities to the stakeholders that own that asset.
Fantastic. Another amazing example of how normalization enables incredible automation at scale.
Yes.
With all this data coming in from multiple systems, because this wouldn't be possible without the main keys in Nucleus and all of the, I know, very difficult engineering that goes into making something like this work. This keeps the Nucleus engineers entertained. Am I right? Building this stuff.
Indeed.
Yeah. So before we wrap this episode, what would you say is the most important thing in a few words for folks to take away?
It's not an easy task, and ultimately at scale with constant API changes from vendors every single day, ensuring that these keys and these values are actually met and the same. It requires tons of overhead and tons of care, countless hours of care and attention that it's not easy for a single team to just do by themselves.
Thank you so much for joining us again on Shortcuts. And I encourage anybody who is especially interested in the asset metadata component of today's talk to go to the very last episode I did with Aaron here about that topic specifically, asset metadata and automation. Check that out. If you want to be notified when future episodes drop and see previous episodes, visit the Nucleus Security channel on YouTube. And we'll see you soon for the next Nucleus Shortcuts. Thanks, Aaron.
Thanks.